Gaia black hole 3. So the name is actually being given as Gaia black hole 3. So it's BH3 means black hole and 3 means the third black hole, just like that. The name is actually Gaia. So regarding this Gaia black hole, that is actually one of the screenshots taken from the astronomy website. It is actually one of the really good websites which actually talks about a lot of discoveries, discoveries and science in the space related activities. So it is a really good site, and this news actually came in the particular site astronomy, and it has been taken up by all of our current affairs on the ClearIAS materials also. So it is actually an important discovery. So why it is an important discovery? It deals with black hole. So whatever news coming out of these black holes will automatically become important because it has been the related topics are continuously being asked in the UPSC exam. So that is why we took the topic. So what is actually the news is that astronomers or the scientists, they uncover the sleeping giant. So that means actually something silent. So what is actually the silent sleeping one? A black hole, and it is a giant black hole. It is a big black hole. It's named Gaia, the largest ever found in the Milky Way. So that is actually the added importance. That is, it is found in our own galaxy. That is Milky Way. So which is our own? What is where is the solar system located or precise? That is actually in the Milky Way galaxy. So it is in the Milky Way galaxy itself. We found another black hole. Another black hole because we have already named some other black holes also. So this is actually not the first black hole located in the Milky Way. So this is and it is actually a dormant black hole, which means that it is not that much active. It is not that much violent. We can say it is actually comparatively not that much actually. That is why it is called a sleeping giant. Then we are actually going into the details of this particular thing. We have to know that it is actually what are the basic details of this thing. It is actually the second closest known black hole to Earth. So there are definitely other black holes in the Milky Way galaxy, definitely, which are actually closest to Earth. So this is the second closest black hole to the air. That is the one point. Second thing, it is actually a giant black hole, right? Which means that it is actually very large compared to that of different stars. For example, it has mass of 32 times that of our sun. So that is actually an extremely good or high or a large black hole. So the 33 times mass of the sun is actually given in this Gaia black hole. So that is the second point. Third point is actually it is actually of stellar origin. So what does the stellar origin mean? It means that the black hole was actually formed because of the collision of one single massive star. So black holes can be formed in multiple ways. Black holes are, so we have to understand what a black hole is ultimately. So talking about a black hole is that it can be formed in multiple ways. One of the ways in which black hole can be formed is from the stellar origin, which means that one single star, like our sun will never become a black hole because our sun is so small. It's a small star only, even though it is actually comparatively very big when it is compared to the planets or Earth, something like that. Sun is actually a very small star. So if to become a black hole, a star has to be something really large. So what is a stellar origin black hole? A single sun-like star or a big star fused together or after a supernova explosion combined together to form a black hole. That means actually it is of stellar origin, which means that there are other types of black holes also. For example, multiple stars can come together. Sometimes it may be because of two heavenly bodies colliding with each other. So different things can happen, which may be the reasons of black hole origin. This particular black hole Gaia is of stellar origin. That is one star combined together, fused together to form. That is imploded to create this particular black hole. That is Gaia. Now we have to understand what is a black hole. So when we are talking about Gaia black hole, we have to talk about the concept of black holes also. So you can actually understand that black hole is definitely the first point which comes to your mind is that the extreme density. We say that it is infinite density. That is density that is so much. When the density is too much, it means it gives rise to intense gravity. So just imagine all the matter of air fusing together in the size of just a matchbox or a mobile phone. So the entire earth is fused together, just compressed together in the shape or the size of a mobile phone, which means that the mobile phone, that particular box will have intense density compared to intense density and compared to the current earth size, which means that whenever the density of that matter increases, the gravity also increases. So a black hole is something that is actually the fused form of the imploded form of that original old star, which means that density is extremely high, infinitely high, which means that the gravity produced by it, the gravitational field created by it, it is also extremely high. So that is the basic fundamental thing which you have to understand about black hole. That is, it is of extreme density, that is extreme gravity. That means that even the light may not be able to escape. So that is the fundamental definition or the informal definition that is actually always said, that is even the light may not be able to escape. That is actually something called, yes, when the light is not able to escape. Why? Because it is of extreme gravity. So all those light which is actually fusing or going to in the direction of that black hole will be trapped in it. So that much intense is the gravity of this particular black hole. And analyzing the basic figure of the cross section of this black hole, we can understand that if a black hole is actually in the center, we have to spot a few things regarding the black hole. One thing is actually about the event horizon. So that is the word event horizon. So what is actually the event horizon? It is the boundary. It is the boundary in which, beyond which, this light may not be able to escape. That is, until that point, light may travel, or anybody can actually travel. But if you cross that line, you fall into the black hole. So just like a cliff. So if there is sea and all, so if you are standing here, just imagine like that. So once you actually fall down here, you will actually eventually fall down into that particular sea actually, or the cliff. Just like that, just after the event horizon, it acts like a cliff. Once you cross the event horizon, there is no coming back. You just fall into the black hole. So that is the boundary, beyond which we actually enter into that particular black hole. One point. The second is actually the accretion disk. So what is actually the accretion disk? It is actually the mass. If a black hole is, just imagine if a black hole is actually swallowing a nearby star or some other planet, something like that. So if the black hole is actually swallowing or eating up that particular planet or a star, the planet actually, because of that intense gravity and all, the planet or star flattens out. It becomes a flat CD-like disk and all. So that round star will become a 2D structure, that is actually a disk-like figure, and it will start revolving around that particular black hole. Why? Because the black hole is actually most probably spinning down. So the entire star will become a 2D like structure. It will keep on spinning around the black hole, and lot of different particles will be going inside that particular black hole. Some will escape also. So lot of different particles will go into the black hole. Some might be able to escape, and some might be able to escape and go out of this particular accretion disk. But most of them will be falling into that particular black hole. So that particular disk which is actually formed when the black hole is actually encountering another mass like a star, that is actually called the accretion disk of a black hole. So that is actually the swirling or revolving mass of matter or star. Matter may be a planet or a star or anything that is actually destined to spiral into the black hole or be ejected into space. So some may be entering, some may cross that event horizon and fall into, some may actually escape out. So that is the second thing. And the third and last thing is actually the relativistic jet. So what happens is that when this black hole is actually swallowing or eating this particular star or other heavenly body, which means that it is a violent event. It is not a peaceful. A lot of energy is being released actually. So some of the energy, some of the energy as well as the matter, when the black hole is actually engulfing that particular star or a heavenly body, that matter or energy is actually released outwards into the form of relativistic jet. So that is the next point, the third word which you have to understand, that is towards both the ends, it actually releases a lot of matter and a lot of energy, which may be spanning off up to around thousands of light years. So it is not a very small length. It is actually spanning about thousands of light years. So that much energy and matter will be released by the black hole, maybe in bidirectional ways or both directional ways. So that is actually the cross-sectional image of a black hole. So that is actually the fundamental thing we have to understand. Then we also have to understand that black holes, the types of black holes can be many. For example, the three types of black holes can be number one is definitely the stellar origin one. So there is once we were talking about the stellar origin, which was actually formed because of one star fusing together, collapsing together. The second thing is actually of intermediate origin. So what is actually the intermediate size of black holes? That actually is when a black hole, the parent star of a black hole is of around 100 times that of the sun, our own sun's mass. Then it is actually called the intermediate black hole. For example, if the 100 to 1 lakh times our sun's mass, then it is actually called the intermediate level black hole. So if a star is actually around 20 times that of our sun, it becomes only a stellar origin black hole only. It is a small black hole only. If a star is actually around 100 times that of our sun, then it may become the intermediate black hole. And the third and last one is definitely the supermassive black holes. Supermassive black holes. So that is the third type, and definitely it is the most largest stars, which will most massive stars that will actually eventually undergo supernova explosions. Then they will finally become the supermassive black holes. And what it is actually, supermassive black holes are formed when stars of mass which are actually having more than 1 billion or 2 billion times that of our own sun's mass, they actually undergo supernova explosion and then become this particular thing called supermassive black holes. There is one last point regarding supermassive black holes is that most of the supermassive black holes which have been discovered by us is actually on the center of galaxies. So most of the supermassive black holes which are being discovered are on the center of the galaxies, which means that our own galaxy, we said that Gaia is not the first ever black hole to be discovered in the Milky Way, right? So in our own galaxy, Milky Way, there is another black hole which is actually called Sagittarius A star. That particular black hole, Sagittarius A star, is a supermassive black hole, and it is actually believed to be expected to be located on the center of our own galaxy, that is Milky Way. So that is actually the topic of Gaia BH3, and you have to also understand the concept of warping of the time. That is actually what is actually regarding the warping of space-time, because whenever we deal with something like a black hole, you have to understand that a black hole, when it is having extreme gravity, extreme density and all, it actually tries to warp the light, which means that we have a general understanding that light always travels in a straight line. But in the recent one of the prelims also, there was a statement that light always travels in straight line. It is actually wrong. Right? Light can generally travels in straight line, but actually it can actually bend and travel also. So can you give one of the instances in which this light can bend? Yes, the major instance is when light is actually traveling through near a heavily gravity body. For example, a black hole or a large star or a star, etc. So everybody, including us, including this pen, including any mobile phone or any other data, any other thing that can have gravity. But when this particular object has got intense density, just of intense size and all, we can actually sense the gravity. For example, Earth. We know that Earth has got its own gravity and all. Just like that, anybody, any person, any matter has got gravity, and it will be the human beings can sense it only if it is on a larger quantity only. So just like that, when this particular light is actually moving, just imagine like that. If a person is standing here in Earth or a moon, and if there is sun here, and if there is a star in this particular location, so this is the actual location of the star. But a person standing from the Earth or a moon, when it is observed, we can feel that it is actually in this particular location. So that is actually the fake location or the pseudo location. We feel that it is the star is actually here. Why? Because the actual light is actually bent by the gravitational field of the sun. So the actual position is actually distorted for us. So that is why the reason is that whatever we see on the sky, that may not be the true location of that particular object, because that object's light, the light coming from that object, might have been distorted by different gravitational field objects. So that may not be the actual location of that particular object. So that is actually called the warping of the space and time. When it is actually what is actually the warping? It is actually the distortion of the space time. So it is not just the space, it is not just the time. The intense gravity, like a black hole, can actually distort the space time. So that is the major important thing when we are dealing with Gaia black hole. So whenever you are encountering such topics like a Gaia black hole or any black hole like that, make sure that you just understand all the basic things surrounding a black hole, all the necessary foundational aspects, and as well as the different current affair things also.